Good morning to you all. I am Dr. Vipul Agrawal and I will be teaching you Modern Satellite Communication System course code 21EC4055. The first topic will be Introduction and History of Satellite Communication. In the satellite communication, we will talk about how the satellite is launched, how it stays in the orbit, what are the applications of satellite, all the mathematical equations involved in satellite communication, how the 5G has got a role to play in satellite communication, what are the different satellites launched till now and what are the applications, what is the frequency allocation, how much signal transmission power is required to transmit the signal from Earth station to the satellite, and what does the satellite do, what is uplink and downlink. All these things we are going to study in our satellite communication subject. So this session is basically about history and introduction to satellite communication. In this session we will also study the advantages and disadvantages of satellite communication along with the basics of satellite, and also we will start this PPT with the history of satellite communication. So theory of satellite. So satellite is something that we will shoot into the space at a right speed and in the correct trajectory, and it will stay up there orbiting Earth for years, if not forever. So as you know, India has keep on sending the satellites into the space, and today whatever we are seeing in the Doordarshan and the cable TV televisions that we are watching, it's all credit goes to the satellite. So the satellite journey was started in 1957, early in October 1957. The signals were coming from Russia's Sputnik 1. So Russia has successfully launched the Sputnik 1 satellite, and it's the first man-made satellite. So a natural satellite would be like a body revolving around a planet. So that will be natural. But if it is being sent by a man, then we will call it as a man-made satellite. So these are the history of satellite. This is a SCORE USA satellite launched in 1958. And then another satellite was launched in 1962 and 1963 with name Telstar 1 and 2. So it was built by Bell Labs. We all know about the NASA. So in 1963, the Hughes Aircraft Corporation launched the experimental SYNCOM-2 for NASA, the world's first geosynchronous communication satellite. It is carried for the first time two satellite call between heads of state when USA President John F. Kennedy in Washington DC telephoned Nigerian Prime Minister Abubakar Balewa in Africa. So basically, when it was launched for the first time, a voice transmission took place by NASA's SYNCOM program. So as you are aware that once we launch the satellite into the space, then the biggest advantage we get is we can easily transmit a voice signal, a video signal, an internet signal and whatnot at a very huge distance, because satellite can cover a large distance. It is up in the air, and once it is up in the air, it can take the signal from the one Earth station and send it to the another Earth station. So as it is mentioned, from Washington DC, it was sent, a voice signal was sent to the Africa. The third SYNCOM satellite transmitted live television coverage of 1964 Olympic Games from Tokyo. So using the satellite, 1964 Olympic Games were first broadcasted using a satellite. So 1965 another satellite ComSat was launched on April 6, 1965, placed in a commercial service after moving into the geosynchronous orbit, 22,300 miles above the equator. So basically we have named various orbit like low Earth orbit, medium Earth orbit and geosynchronous Earth orbit. So geosynchronous Earth orbit is the farthest of all the orbit, and it is located at around 35,000 kilometers from the equator. So since we always measure the distance from the equator because Earth is spherical, so if you go by the distance, like the distance may change if you measure the satellite distance with the polar region. So what we often do is, whenever we are measuring the distance, we measure above the equator. We consider the equator is the surface of the Earth, from there we measure. So the distance of geosynchronous orbit is 35,000 to 36,000 kilometer above the Earth. it is provided the line of sight communication between Europe and North America. So what does line of sight means? Line of sight means there is no obstruction. So satellite actually can see two countries together without an obstruction. So in a Earth, as you know, that back side of the Earth may not be visible by a satellite. So you may need another satellite, but if the Earth is in the front, then it can easily see. So I will just try to explain this. If this is your Earth and this is your satellite, so satellite can see both this space as well as this space. So we call it as a line of sight because both are visible. Now the back side of the Earth is not visible, this portion, back side of the Earth. So this area satellite will not be able to transmit anything. So for that we may use another satellite. So another satellite we may use at the back side. It may transmit to this satellite and then it may give it to the back side. That is called a handover. So but in the beginning of the satellite communication, as we are reading the history, first we are mainly focusing on the basic things that satellite can do. So line of sight is basically the area which the satellite can view and can transmit from one place and transmit to the other place. The early bird didn't have a battery and worked only when its solar panels were exposed to the sun. So nowadays the batteries are such that during the daytime the solar panel will work and the solar panel will charge the battery. So and during the night time the charged battery will take over from the solar panel and then they will power the batteries. They will power the satellite. So these are the important milestones. 1972 first domestic satellite system operational in Canada was successfully launched, and then 1975 USA India collaboration, the satellite was launched. In 1977 direct to home satellite broadcasting was launched, which we call a D2H. So 1979 International Mobile Satellite Organization IMERSAT established, and later on they also launched their own satellites. So these are again from 1981 to 1989 various satellites being launched by various countries. These are the milestones 90 to 95. Several organizations proposed the use of non-geostationary satellite system for mobile communication. Again, as I said, geostationary is very far away, 36,000 kilometers. So non-geostationary means any orbit below 35,000 kilometers. So earlier satellite we have launched in the geostationary. There are various advantages of a geostationary orbit, that the satellite can cover larger distance and it revolves with the Earth. So it is always available. Like some satellite may not be available because Earth is rotating and satellite is also orbiting around the Earth. So a time may come where the country which is using the satellite may not be having the line of sight with the satellite. But with geostationary that limitation is not there. Geostationary will be the time period of the revolution of the Earth will match with the satellite and it will always be available. So in 1995 the first time it was proposed that a satellite to be launched in the non-geostationary orbit. So again 1997, 1998, 1999 Global Star initiates service, 2000 ICO initiates service, Iridium failed system is being sold to Boeing. So basically various companies have launched their own satellite and then they used to charge some amount from various companies if they want their services. And one of those private companies is Global Star Service and Iridium Service. So from 2001 again Astra 1H was launched, and 2001 AP Star 5th, a geo satellite served Asia, was used. So now let us come to the basic working of the satellite communication. Now if you see the ground equipment, the one where it is written, the ground equipment transmit the signal to the satellite. Now if you can clearly see both the antennas that are mentioned in point number 1 and 4 are both having a line of sight communication with the satellite, because both can see the satellite. So what does the satellite do? The ground station transmits the signal to a satellite. It is clearly mentioned, the ground equipment transmits the signal to the satellite. Now what does satellite do? The satellite amplifies the incoming signal. Why amplification is required? Because as the signal is traveling in the air, there will be path loss. Because of that, as the signal reaches the satellite, it has already weakened to an extent that we need to amplify it. So there is an amplifier, low noise amplifier in that satellite, which will amplify the signal, and it will change the frequency. And why the frequency is need to be changed? Because if you transmit the same frequency back, there is a high possibility that these two frequency will interfere. So if this is the frequency that is being transmitted, then the satellite, if it's transmit the same frequency, then there may be an interference that may happen here, and that interference may destroy all the data. So as we all know, in communication we have divided the frequencies. For example, cellular mobile communication, we use 900 megahertz. Okay, similarly satellite, we are using a gigahertz frequency range. We will see the frequency range in the coming classes. So basically different frequency is very important. If we use the same frequency, it is going to interfere and the data is going to be lost. So first, when it is being transmitted, this signal can either be your video signal, voice signal, or any kind of a data it can transmit. When it reaches the satellite changes, amplifies it first, and then it changes the frequency, and after changing the frequency, it transmits back to the Earth station, that is the Earth station 2. So the ground equipment again receives the signal. So two important things satellite do: first, it amplifies, and the second, it after changes the frequency. Okay, and then it transmits the signal back to the other ground station. So imagine if a cricket match is happening in this locality, in this place, it can be easily given to this this antenna. In this, you can say this cricket match is happening in India, it is being transmitted, and now the same satellite will send this video signal of the live cricket to Australia. So often you would be surprised to know that there is always a delay. So when you are asked, if you call someone, or if you really see the delay, if you want to observe the delay, you would be surprised that the person who is watching the cricket match, and when he sees the same cricket match in a TV channel, and there is a possibility that there can be a 3-second, 4-second delay in what he is watching and what is being broadcasted in the channel. The reason behind is the propagation delay that will be caused. So one of the, as I said, one of the advantage of geostationary satellite was it is very far away and it covers very large area, and it's always available because it moves along with the Earth. So that country which is using the geostationary will have that satellite every time. But one of the drawback will be there will be high propagation delay, because geostationary orbit is a very farthest orbit, that is around 36,000 kilometers away. So this, if you observe, this is the Earth station, and so this is your Earth station, where this is your downlink and this is uplink. Uplink basically means that when a signal is transmitted from the Earth station to satellite, we call it an uplink transmission. And when the satellite transmits the signal to the other Earth station back, we call it as a downlink. So it is very important, because when we use the word uplink frequency, it should be understood that the ground station is transmitting to the satellite. When we say downlink, then we say that a signal is being transmitted from satellite to the other Earth station. So other Earth stations receive message in a useful strength area. So the good thing about satellite is it can cover a large area. So large footprint we say it can cover. So what are the advantages? Global coverage, reliability, wide bandwidth, low latency. Latency means delay. So in geostationary satellite delay is more, no doubt, but in low Earth orbit delay becomes very less, negligible. And also in geostationary satellite the delay can be around 5 seconds, which can be accepted in many cases, or I should say 3 seconds, 2 seconds, which is easily acceptable. Mobility means you can move around without any problem, and while you are moving around then there will be no issue, because satellite communication can be used for mobile applications. So like in fixed landline, what happens, you have to be at a particular place, but in satellite communication, if you are using a satellite communication, you can move around. Scalability means large area can be covered, and satellite networks can be easily expanded by launching additional satellite to meet the increasing demand for communication services. So here scalability means that we can increase more number of countries that can be served by satellite. How? Because if more countries come into picture, then more satellite we can launch it. So even in satellite to satellite transmission can also take place. For example, if this is your Earth and this is your satellite, so if one signal is transmitted through this satellite, then this signal can further be given to another satellite, and this signal can further be given to another satellite. In this way, many areas of the Earth can be taken care of if the number of satellite increases. So that is what scalability means. We can increase it and cover the entire Earth. Security, our satellite data is encrypted. There is some kind of coding being done so that nobody can get the data what is being transmitted. Disaster recovery means satellite play a crucial role in disaster management recovery by providing emergency communication links where terrestrial infrastructure is damaged. Imagine the earthquake has taken place, so all the buildings with video cameras and antennas may get destroyed, but our satellite in the space will remain intact and can help in many ways. Broadcasting, satellite are used for television and radio broadcasting. Environmental monitoring, satellite are instrumental in monitoring the collecting the data. Remote sensing, satellites equipped with sensors and camera are used to remote sense applications including agriculture. Interconnectivity, satellites enable the interconnection of remote locations, remote healthcare, education and business operations. So many times you will go into the village area where there is no network, no signal, but satellite can actually help in providing the signal in that area. Nowadays satellites are available where if a particular person goes into the ocean in a region and for his security he wants the signal so that his location can be tracked, and there are few commercial satellites available which will provide the signal in that area. So this much satellite services are available. Redundancy, satellite can serve backup communication option in case of terrestrial network fails. Multicast service, satellite communication allows for efficient distribution of content to multiple recipients simultaneously. So it's not only that satellite can take it from one station, give it to another station, it can give it back to 10 stations, 15 stations, so it can serve many countries. Long term investment, once in orbit, initially it will be a little bit expensive to launch, but once in the orbit it's going to have lot of functions, and it can serve in many ways. Versatility, satellites can support in various communication service like voice, data, video, making them a versatile solution for a diverse applications. So disadvantages are latency, that is delay, high delay especially for geostationary satellite. Cost, so cost is obviously very high. You are launching satellite, so it will be of very high amount. Weather dependency, satellite signal can be adversely affected by the poor weather conditions such as heavy rain or storms, or causing signal degradation or interruptions. Geostationary orbit limitation, geostationary satellite fixed, everybody wants to transmit in geostationary, so basically once you transmit in the geostationary, it comes on the top of the earth, but in geostationary the polar regions are not being able to, is the satellite is located in the geostationary orbit cannot serve properly to polar regions because of its location. So complex infrastructure, security concerns, and obsolescence, limited spectrum and energy consumption, these are other the disadvantages. Thank you.